dear students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So today I will discuss you about all the factor that is affecting this anaerobic digestion process. Because in the last class I have explained you about the anaerobic digestion, like why this anaerobic digestion and what is the process inside this anaerobic digestion chamber. So here what happened, microbes are there, some microbial activity will be there, and that too in the absence of oxygen. So in the absence of oxygen, microbes have the capacity, so they will degrade all the organic matters from the solid waste, and some useful material will be come out. So for this, biogas plants is there, and we already know that biogas plant is working on this anaerobic digestion process. So today I will discuss about the factor which is responsible for this anaerobic digestion. So first of all, what is anaerobic digestion? Means what is the meaning of this digestion and what is happen inside this chamber? So anaerobic digestion is a controlled process that will basically involves the microbial decomposition of organic matters in the absence of oxygen. This is the main thing, that is microbial decomposition process will starts inside the chamber that is in the absence of oxygen. And this definition has been given by the Municipal Solid Waste Management 2018 manuals. Okay. So in the government of India has made a manual that is on the municipal solid waste management and its handling in the year 2018. So this management, as per this manual, anaerobic digestion is called as a controlled chamber. Inside a chamber, a controlled experiments are there which is in the absence of oxygen, and that process will involve the decomposition process of an organic matter in the absence of oxygen. Okay. So this anaerobic digestion involves the process of decaying biodegradable materials in the absence of any terminal electron acceptors like sulfate, nitrate and oxygen. And next point is that anaerobic digestion consists of a number of complex biochemical reaction that will be carried out for several type of microorganism that microorganism will be able to survive in the oxygen free condition. So this anaerobic digestion will involve a series of reaction, like hydrolysis process will be there. Then after acetogenic process, acidogenesis process, then methanogenic process are there. So first is hydrolysis, that is involves in the presence of water is there, and after some acetogenic bacteria is there, and then acidogenesis bacteria is there, and then after methanogenic bacteria are there. So all these microbial bacteria are the microbes that have a capacity to survive in the absence of oxygen. So these are the steps. First one is the hydrolysis step, then after acetogenesis step, then after next step is there, that is acidogenesis, then our final step is there, that is methanogenesis. Okay. So with all these steps, some bacteria are there, some microbial activities were there, that decomposition of organic matters, all the organic matters present in the MSW will be converted to biogas, will be converted to a useful material. So and in the absence of oxygen, in the absence of oxygen, anaerobic digestion is like absence of oxygen. The microbial reaction in the absence of oxygen, microbial decomposition activity in the absence of oxygen is called as anaerobic digestion process. And it is a controlled process, means factors are very much important for this process, for this anaerobic digestion. So factors like, now we will discuss about the factors. What are the factors? And this decaying process will be there for the biodegradable materials. All the either biodegradable material and organic matters in a solid waste, it will be decomposed by some microbial activity in the absence of oxygen, and that microbes are like that, they will be able to survive in the absence of oxygen condition. So during this process, what happened, biogas is produced, which is mainly of microalgae. So biogas is there. After means all the steps I have explained you, like hydrolysis process will be there, acetogenic process, acidogenesis, then methanogenesis. So when all the process will involve, and after that the final result will come out that is called as biogas. The final product of this anaerobic digestion is the biogas, and this biogas is mainly composed of CH4, that is methane. So main thing is there that methane is there. So when we talk about the composition of this biogas is the basically the methane and carbon dioxide. So methane is CH4 and carbon dioxide is CO2. And methane is the primary components, means the composition of methane is more when we compare it with the other gases. If we talk about the composition of this biogas, then methane is there, carbon dioxide is there, hydrogen sulfide is there, nitrogen is there, and hydrogen is there, and some water vapor. So what happened? CH4, CO2, then next is the hydrogen sulfide, then nitrogen, then hydrogen only, then water vapors. Okay, so these are the basic composition of this biogas, but most of the gas, up to 75 to 80% composition is the methane only. 75 to 80% total composition is the methane only, and rest of the composition like 25% or 30% is all these gases like CO2, hydrogen sulfide, oxygen, nitrogen, some hydrogen, some water vapors are there. And next thing is related with this anaerobic digestion. In this the material, after this digestion process, one material will be left out. That material after this anaerobic digestion, that material is called as digestate. So digestate is there after this material anaerobic digestion. So digestate is also again a wet mixture liquid. So when this all process will be completed, we will get the biogas. So after that, one leftover thing is there, that is called as digestate. So this digestate is a wet mixture, like that can be separated into a solid and a liquid, and this is also a very useful material. So digestate can be also used for in agriculture or in a crop development. Okay, so what happened? The composition, we have talked about the composition of biogas, like most of the, like 80% of the composition of biogas is methane, and rest of the 20% is like all gases, that is carbon dioxide, hydrogen sulfide, nitrogen, hydrogen, and water vapors are there. And after this anaerobic digestion, one liquid will be left out. That liquid is called as digestate, and which is very much rich in nutrient also. This digestate is rich in nutrients. Okay, and digestate, we can say that it is a wet mixture that can be separated into either in a solid or in a liquid. And now we'll talk about the factors. What are the important factors that is related for this anaerobic digestion process? Because anaerobic digestion process is like a controlled microbial decomposition of organic matter in the absence of oxygen. So first point is the temperature. We'll talk about the temperature. Temperature is also a physicochemical property that is very much important for this anaerobic digestion. So the parameter play a major role in physical and chemical properties of a substrate, which affects the thermodynamic and kinetic reaction inside the anaerobic reactor. So this temperature, what it will do, it will be like physical and chemical properties of substrate, and it is going to affect the thermodynamic and kinetic reaction inside the anaerobic reactor. So thermodynamic reaction will be there and some kinetic reaction will be there. So that both of the reaction takes place with the in that reaction, temperature is again a very important part. So the parameters play a major role in the physical and chemical properties of the substrate. Like thermodynamic reaction will be takes place, some kinetic reaction will be takes place, so that this temperature inside the reactor, that's why the temperature is very important. So this anaerobic process, it will takes place inside a 3 temperature condition. Okay, so 3 temperature condition, and the bacteria and the microbes activity can takes place inside the 3 temperature condition will be there. First condition is psychrophilic, that is less than 20 degrees Celsius. If less than 20 degrees Celsius, then psychrophilic condition will be there. Then again mesophilic, that is like 20 to 45 degrees Celsius. This is the ideal range. 20 to 45 degrees Celsius of temperature is the ideal range, and mesophilic bacteria are there that will be able to survive in this condition, and that bacteria will having a more impact for this microbial activity. And next is the, if temperature will be increased like more than 45 degrees Celsius, that condition is called as thermophilic phase. So three phase, we have discussed about the three phase. First was the psychrophilic, mesophilic and thermophilic. If the temperature will be increased more than 45 to 65 degrees Celsius, that will be like thermophilic stage. And this stage is called as a final stage or maturation stage. So thermophilic stage is called as the final stage where microbes activity will be takes place and they have done their job. All the microbial activity has done their job and the final stage is there, that is 45 to 65 degrees Celsius, where the anaerobic digestion has been completed. That's why the 45 to 65 degree temperature, and that temperature is more. Next, you can see that this is the temperature inside this bin. So what happened? Three condition is there. Growth rate, methanogen. So rate of reaction doubles for every 10 degrees Celsius rise in the temperature up to a optimum, after which reaction rate declines rapidly. So this slide is about the how this temperature changes for this inside the anaerobic digestion chamber. So temperature, first one is the cyclophilic, mesophilic and thermophilic. So up to like 0 to 20 degrees Celsius is cyclophilic, and after that 40 degrees Celsius of temperature, here you can see that this will be like mesophilous conditions is there. Then after thermophilous, that will be more than 60 degrees Celsius, 45 to 65 degrees Celsius of temperature, and rate of reaction double for every 10 degrees Celsius rise in temperature. So what happened? The rate of reaction is going to be double for every 10 degrees Celsius rise in temperature. That will be up to an optimum, after which reaction rate decline rapidly. So up to the optimum temperature is mostly 65 degrees Celsius. 65 degrees Celsius is the optimum range of a temperature. So when the temperature starts rising up to like for 10 degrees Celsius and more than 10 degrees Celsius, so this difference will create the rate of reaction decline rapidly, and the rate of reaction will be doubled when up to increase of every 10 degrees Celsius. So up to increase of every 10 degrees Celsius, the rate of reaction is doubled and the temperature is like up to a optimum, after which reaction rate declines rapidly. So up to up to when optimum condition will reach like 65 degrees Celsius is the optimum temperature condition. So when this condition will reach, then what happens? Then the reaction rate is going to be decline. So up to 65 degrees Celsius only is the best and ideal condition. And if the temperature will be increased more than 65 degrees Celsius, here what happens? The reaction rate of this microbial activity is going to be decline. So and that decline will be like rapidly. So this reaction rate will be decline after increasing more than 65 degrees Celsius, and the rate of reaction is double for every 10 degrees Celsius rise in temperature, and it will be up to optimum, after which reaction rate declines rapidly. So what happened? The thermophilic range is like generally have several effects over the lower range. So some positive effects are like that. What happened? So in the thermophilic temperature range, they have over a lower range. So increase in hydrolyzed soluble product, which make them more accessible to microorganism. So what happened? The hydrolyzed soluble products are there, which will be like more accessible to the microorganisms. These are the some positive effects that will be related with the lower range of temperature. Because after the thermophilic range, like more than 65 degrees Celsius, that condition will be not much suitable. So what are the positive effect within the lower range of temperature? Next is the increased reaction kinetics in both chemical and biological processes. So the reaction kinetic will be increases inside the chemical and biological process. So shortening the reaction time and hence the HRT, the hydraulic retention time of the reactor. So the reaction kinetics reaction of the chemical and biological process shortening, it will shorten the reaction time and hence the HRT, like the hydraulic retention time of the reactor. Next point is that it improves the physico-chemical properties of the soluble substances. So what this thermophilic range will do, like in the lower range, it is going to improve the physico-chemical properties of the soluble substrate. soluble substrate which is present in the organic matter of the waste. Okay, so the soluble substrate are there that will be improve the physicochemical properties. The physicochemical properties of this soluble substrate is going to be improved because of this thermophilic temperature range. And now we'll discuss about the negative effects of thermophilic temperature range. Like if the temperature range will be more than 65 degrees Celsius, then what happen? So the increase in the fraction of the free ammonia, which is inhibitory to the microorganism. So what happen? Ammonia is going to be released. So this ammonia is not good for the microbial activity, and ammonia inhibition could disturb the whole anaerobic digestion process and dynamics and may hamper the quality of the gases. So this ammonia, what it will do? It will hamper the whole process. So this ammonia, if ammonia will be released, that is going to be disturb the fraction of free ammonia, inhibitory for the microorganism. And next is the reactor stability is also reduced, and high accumulation of volatile fatty acid occurs, which affects the growth rate of the methanogens. And effluent quality reduces the toxic increase of certain type of substrate. So here some few points are there. That few points are related with the negative effects of thermophilic temperature range. So when the temperature range will increases, so ammonia will be released. And what this ammonia will done? This ammonia is like inhibitory and could disturb the whole anaerobic digestion process, like dynamic, and may hamper the quality of the gases. So it will disturb the whole anaerobic digestion process and hamper the quality of the gases. Means the gases quality will be affected, and the quality of gases is not good. So what happen? If the it will disturb the composition of the biogas. In this way, will not get the good quality of biogas, and the mostly what happen? Volatile fatty acid will be released. So this volatile fatty acid will affect the growth of all the methanogens and microbes. And effluent quality reduces and toxicity increases for certain type of substrates. Next is the hydrolysis process. So for hydrolysis process, the mesophilic range, what it will do? For the mesophilic range, like 20 degrees Celsius to 45 degrees Celsius. So this mesophilic is like middle. So they have the positive side is that they have the greater process stability and better richness in anaerobic bacteria. So these condition is having ideal condition, and that condition is like it will be having greater process of stability and better richness is anaerobic digestion bacteria. Next, we'll talk about the disadvantage of this mesophilic temperature range. So disadvantage is like that it will provide lesser biogas yield in comparison to the thermophilic anaerobic digestion process. Optimum temperature range for anaerobic digestion can be hydrolysis in thermophilic range and methanogenesis in mesophilic range. But the various other factors also need to be ascertained before deciding the range of temperature for the anaerobic digestion process of any type of substrate. And one more point is that like too higher temperature may causes the metabolic rate of decline due to degradation of enzymes which are critical for the life of the cell. So high temperature is also not good for the metabolic rate of this bacteria's microbial activity. So the ideal temperature for this hydrolysis process is like mesophilic condition, mesophilic temperature range 20 degrees Celsius to 45 degrees Celsius. And too high temperature and the medium temperature is also good. So mesophilic range, various other factors are also there that is needs to be ascertained before deciding the range of temperature for the anaerobic digestion. So the various some other factors are also there. That factors like it will be helpful for deciding the range of temperature for the anaerobic digestion process of any type of substrate. Next factor is the pH. So this parameter affect the overall efficiency of the digestion process. So pH will be increases the overall efficiency of the anaerobic digestion condition. And methanogens are there. These methanogens are effective in the pH range of 6.5 to 7.5. So next we'll discuss about the pH. So the pH range is ideal range for pH is 6.5 to 7.5. like this 6.5 and 7.5, and the pH varies due to the parameter like volatile fatty acid, bicarbonate concentration, and alkalinity of the system, and also by the fraction of carbon dioxide produces during the anaerobic digestion. So pH will be vary because of the volatile fatty acid, bicarbonate concentration, and alkalinity of the system, and also by fraction of carbon dioxide. And to maintain a constant pH value, it is essential to stop the relationship between the volatile fatty acid and bicarbonate concentration. So maintaining the buffering capacity of the biogas digester. So to maintain the buffering capacity of the biogas digester, this volatile fatty acid and pH should be maintained, and it is essential to control the relationship between the VFA and bicarbonate concentration. And one of the risks for digester failure may be related to the excessive accumulation of volatile fatty acids in the biogas digester. So the main risk for this digester failure is related to the excessive accumulation of volatile fatty acid in a biogas digester. The acidogenic bacteria are there. They can be flourish, lowering the pH less than 5.5, inhibiting growth of a methanogens. And if pH will be more than 8, that proves to be toxic to most anaerobic and anaerobes, which inhibits biological function of the anaerobic digestion process. So now we'll talk about the two main operational methods. So for this whole operation methods for correcting an unbalanced low pH condition in the digester. So the first approach is to stop the feed and allow the methanogens population time to reduces the fatty acid concentration, and thus raise the pH to an acceptable level of the at least 6.8. So the first approach is to stop the feed and allow the methanogens population time to reduces the fatty acid concentration, thus the pH out to an acceptable level of the at least 6.8. So if the temperature will if the pH will be less than 5.0 5, that will also inhibit the growth of methanogens. If the pH will also more than 8, that is also a toxic. So the ideal range is 5 to 7 for this anaerobic digestion process. See, this is the picture. This is showing how this is methods involves the addition of chemicals to raise the pH and provide additional buffer capacity. So an advantage of chemical addition is that the pH can be stabilized immediately and the unbalanced population is allowed to correct themselves more quickly. So pH dependent methanogens are there. So this activity is there, and relative activity of methanogens to the pH. So stable activity of methanogens is like that, and optimum pH range for anaerobic digestion is 6.8 to 7.2. So 6.8 to 7.2 is the optimum range of the pH. If it will be less than 6, that also affected. If more than 7, that also affected. So advantage of chemical addition in that the pH can be stabilized immediately and the unbalanced population is allowed to correct themselves more quickly. Now the next is the buffering capacity, like alkalinity. So anaerobic digestion process has its own buffering capacity against pH drop due to the production of alkalinity during anaerobic digestion process. So its example we can say that degradation of protein present in any substrate releases ammonia, and that reacts with carbon dioxide and produces ammonium carbonate as alkalinity. So ammonia is there, ammonia plus H2O plus CO2. That will gives ammonium carbonate, NH4, HCO3. This is called as ammonium carbonate. A degradation of salts of fatty acid may produce some alkalinity, and that reaction is like this is the reaction. CH3COO Na plus H2O will gives methane plus NaHCO3. So this is about the buffering capacity alkalinity. Sulfate and sulfide reduction also generate alkalinity, the reaction of which can be shown like this: CH3COO plus SO4 2 minus will gives HS. So what happens when the pH in an anaerobic system drops due to volatile fatty acid accumulation? The alkalinity present within the system neutralizes the acid and prevents further pH drops. If the alkalinity present is insufficient to buffer the system pH, external alkalinity addition are necessary. So what happens If the alkalinity that is present is insufficient to buffer the system pH, external alkalinity addition are to be added to maintain this ratio of the sulfate and sulfite reduction which generate alkalinity. So these are some of the references that I have used. These are the references of some of the textbook which I have followed for this lecture. If you want to go depth in this study, you will go and you will find out some of the useful materials for this. So this is the references of some of the textbook that is related with this study that I have followed for this study. Okay, so in this lecture, I have discussed you about the anaerobic digestion and what are the important factor that is affecting this anaerobic digestion process. So first of all, anaerobic digestion process is a process which can take place in the absence of oxygen. Microbial activity will be there, and that microbial activity will decompose the organic matters from the solid waste, and that decomposition in the absence of oxygen. So we will provide some optimum range of every factors for the anaerobic digestion process. So the product will be coming out with this anaerobic digestion is a biogas, and this biogas is very much useful. So some of the important factors that will be required for this anaerobic digestion process, because what happens when the optimum condition will be not there for this anaerobic digestion process, then the output, then the biogas will not be of good quality. So important factors are there is the temperature. Temperature is a very important factor for this anaerobic digestion process, because in the presence of temperature only that microbial activity can be takes place. So the ideal range is like 20 to 40 degrees Celsius. Three condition for this temperature is like less than 20 degrees Celsius, 20 to 45 degrees Celsius, that is mesophilic range, and mesophilic range is the ideal range, and 45 degrees Celsius to 65 degrees Celsius is the thermophilic range. After that, no reaction can take place. So now at this point, I am concluding my lecture. Thank you for today's lecture. If you have any query, if you have any question, you will write me to my mail ID shikha.pandy@gmail.com, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.